So we're starting off this lesson with some vocabulary. This isn't in your note sheet, so if you go to my Unit 2 page, you'll see a vocabulary part 2 note sheet that you can pull into Notability and mark this up as you follow along with me. So first we're going to talk about what's called the rational root theorem. That's what I referred to it as if you had me in Algebra 2 last year. This book calls it the rational zero test, so you'll need to be familiar with both terms so you know how to apply it. It looks pretty complicated, but when it comes down to applying it, it's actually relatively straightforward. So let f of x be a function, a polynomial function. So notice how all of these x's are to some power. The power is not x. All the way down to q, which is our constant. Notice q is not being multiplied by an x. So a is the leading coefficient, and q is the constant. If f of x has a rational root. Now let's make sure we understand what the word rational means. Rational numbers are all integers, all decimals that terminate or repeat, meaning they could be rewritten as a fraction, an integer over an integer. This is not helpful for if the function has a radical or irrational root or an imaginary root. This will only tell us if it has a rational root. If it does, it will be in the form of factor of q, the constant, over a factor of a, the leading coefficient. So let's see how to apply this. Our first example, if you go back to your note sheet, is simply listing the possible rational zeros. Again, notice that word possible. It does not mean that any of these actually are zeros of the function. It just means if it has a rational zero, it will be one of these options. So we're going to start by listing the factors of the constant, in this case 6, both positive and negative. So notice I've listed all of the numbers that go into 6 evenly. That's what a factor is. And then we will take all of these are possibilities and all of these divided by the factors of the lead coefficient. Well, lucky for us, our lead coefficient is 1. If we divide all of these by positive or negative 1, we're going to get minus plus 1, minus plus 2, etc. So these are the only possibilities for this function. Now, if you pulled up the note sheet, you'll see this little graph. This is the graph of the function that I just gave you. Now, notice that it appears to have a 0 at 2, and it appears to have a 0 at negative 1. Those are in our list. Positive 2 and negative 1 are in our list of possible rational zeros. Notice also that not all of our list show up as zeros of our function. So again, these are only possibilities. They are not guaranteed zeros. And again, it's not guaranteed that our function will even have a rational zero. What it says is if it does, it will be in this list.